Hello. Good evening, members. I want to welcome all of you to this session, our second session in programming. I can see we have some of our members on. I want to welcome Ngora Girls Secondary School, as well as Padibe Girls Comprehensive ICT Club. My name is Emmanuel Muboki. I will be your presenter today as we go through some of the basics of Scratch programming. So I'm glad that at least you've taken the time to make it to this session, this hot afternoon on Saturday. So today we shall be learning the basics of block coding, and this will be supplementing our first session, that is session 1. I'm assuming that you were able to actually have a look at our session 1. Welcome, Mr. Opolot. You're very welcome. Thank you. Yes. Okay. So as I was saying, we are going to be working on a few programs, and I'll be showing you how you can help your learners and our ICT club members to start building some programs, some video games, some stories, creative things, in other words, how they can actually take advantage of the Scratch interface and the Scratch program and application, so that they can also get used to this element of programming. So why we decided to first start with block coding or Scratch programming is because we want to build a very solid foundation relating to programming. Yeah, because we believe that some students were reaching out to me and asking me, why don't we just jump into the complex things? And I thought that that wouldn't be a very good approach to what we are trying to achieve here at Kawa, at UCC, and the rest of our partners. We believe that if we build a solid foundation, we shall be able to support our learners, irrespective of their age, and be able to make sure that we show them how they will be able to progressively move from maybe a fundamental level and be able to program even more complex applications. Yeah. So actually, this week, they had suggested that maybe I should share with you, with the ICT club members, maybe HTML or CSS, and I had to explain to them that block coding is actually better to build a foundation in terms of programming. So I'm just going to briefly share my screen here as we proceed. Yeah. All right. So I hope everyone can see my screen. So just like I mentioned, today we shall be looking at Scratch, but block coding in general. I believe that this will be a good start to the many great things that are going to be happening in the ICT club, because we've been realizing that whenever we have the NCC competitions around the country, we've realized that only a few schools get to participate. And we saw that one of the biggest challenges as to why, and the reasons as to why we don't actually get some schools participating is because they lack the capacity, not only the capacity, but as well as the mentorship to be able to participate in some of these programs. So that's why we came up with this particular initiative to help our ICT members at least get a chance to interact with us, as well as be able to learn one or two things every weekend. We believe that it will also help us to engage with the ICT teachers they can as well share with us some of their problems. What are the challenges? What are they working on, and how can we help? So we believe that this will sort of create a joint interface with not only the ICT club members, but as well as the partners that we are working with to make sure that this happens successfully. So today, I want to have at least a brief recap of what we covered in the last session to make sure that at least our members haven't forgotten and they haven't left those fundamental concepts that I shared in session 1. Please, I want to request our, someone should mute.
Just a moment.
Someone should mute. Someone from Sogalite, please mute. That inconveniences the rest of the listeners. So as I was saying, I want to recap session 1, sorry, so that we keep whatever we covered in mind. So, so today's agenda is also brief. We have only 1.5 hours. We shall be stopping at 4:30. I want to run through this quite quickly because, like I've just mentioned, we want this session to be as practical as they can be, so that our learners get to do more practical things than just getting maybe to understand definitions, understanding the theoretical part of programming, because programming as a discipline is mostly a practical activity, sort of. Yeah. So today I'll be sharing with you a recap of our session 1, just highlighting the fundamentals, the fundamental concepts that I shared last time. At least my best 3 slides that I think an ICT club member shouldn't forget. Then secondly, I'll introduce our members to another ICT concept called block coding, and how we use blocks to build programs rather than text or characters. So I'll also be showing you two main interfaces or IDEs that we use in terms of block coding. They are also considered as programming languages, but in this case, we shall be looking at one programming language called Scratch, because Scratch and Pictoblox are two sort of similar. They are all sort of similar interfaces, graphical user interfaces, but they use one language called Scratch, because Scratch is a visual programming language. Sorry. So I will also be able to demonstrate briefly, because we really want our members to take advantage of the computers. We want them to take advantage of the computers at the school. The computers should not be covered throughout the week, because in most schools, as we're moving around with Mr. Wamanga, I realized that most of the computers were actually kept in stores. There was a lot of dust on them. Students only use them on special occasions, which we think sort of impedes the goal that we are trying to achieve with UCC, as well as the rest of the partners. We believe that computers should be used because a lot of money is being spent on these computers. And we believe that if we can show the learners, we can show the teachers how best they can use the computers, we believe that they can gain optimal value from these computers. So finally, we'll also have a small period of 30 minutes where we shall share some ideas. We can exchange ideas on what our learners maybe have experienced, what have they learned today, what are they working on, what are they looking forward to learning. So I always have a Q&A session where I give an opportunity to the teachers as well as the learners, because as I mentioned, we are supposed to have an engaging session, not just a session of where I come here and sort of just share with you ideas and go away. We think that's not the best way of doing things, and that's why we've adapted this approach of sharing information, sharing and updating each other on what's going on, not only at the schools as well as on our side, what we are bringing, what devices we have, something similar to that. So in our session 1, I covered certain things that I want us to really consider. So some of the terminology, I think the most important thing that I shared in session 1, and I'll repeat, if you didn't get a chance to see our session 1, you can get it from the patrons group. We shared it there. You can as well maybe ask other members or teachers to share with you that session 1. It's also now on the Kawa platform on YouTube. You can as well go and see that session 1. You simply search for session 1 Kawa ICT Club presentation. Then you'll be able to see our session 1. So I explained a lot of terminology, like I gave the definitions of programming, what is a programming language, what is a computer, what is a linker. These are some of the basics that we have no doubt that the ICT teachers have shared with some of you in the ICT classes. But we also wanted those who are not in the ICT class to also get a chance to learn some of these things. So we hope that when you go through our session 1, or for those who were able to attend, you remember most of the terminologies. We know that at least by now, you can be able to differentiate between a program, an application, and a system. You know what we mean by that. You shouldn't use those words interchangeably or in the wrong context. Don't say I'm developing an application when whatever program you're writing has no interface that a user can use. Don't say you're developing a system when you're developing only a single program, and your system maybe your program has no other devices attached that are also using different softwares. So we gave all those examples in session 1. So I think by now we know at least the different types of programming languages, and I think each student at least by now should be able to understand what are the types of programming languages. What do we mean when we say a high-level language? What do we mean when we say a low-level language? When someone asks you tomorrow, maybe an ICT teacher or a friend wants to learn and asks you, please give me some examples of intermediate programming languages. Can you give those examples? So this is why we are bringing this awareness to the ICT club members, so that when they even come for the competitions, or when they're at home and their young brother is asking them, what is a programming language, they can be able to give an intelligent answer as members of the ICT club. That's why we formed the ICT club even from the beginning, to be able to impart some of this knowledge and skills. So we shall also, I'm just going to assume that at least by now, an ICT club member knows how a program works, and it's not just about knowing, but also being able to describe it intelligently from a perspective of what encompasses a computer. How is a programming language translated into machine code? Do you know the definition of machine code? Do you know the definition of byte code? So do you know other words that might mean that might mean the same thing? So that's why I had to share that in session 1. So we also had a brief description of how someone can actually plan and design for a basic program. I was able to share with you my slide that I thought would really be one of the key slides in the presentation. So it had 7 stages that I think an intelligent and cautious programmer should be able to go through, at least at a basic level. So there are many ways of representing the software development process, but I try to summarize it in as a simple way as I could. So I outlined some of these steps where we said that you always have to begin with an overall goal in mind. You have to know what you're going to develop. You don't just jump into your editor on your computer, or just jump into it straight away and just start coding away, which is the habit of most programmers when they're starting out. Even professionals sometimes do that, but professionals can do that because they've had a lot of experience. But for our members who are just starting out, really encourage you to go through all these 7 steps so that you can be able to have at least to structure out what you're going to be developing, such that when you reach your computer, things become very, very easy and you see that things start flowing. When you get stuck, you simply go back to you look through the processes of the design and plan process, and then you realize where the mistake is. So just to summarize, we began with an overall goal, where, for example, I gave an example where an ICT club member says we are going to develop a website that will be able to show the world what we are doing at our school. That is quite an impressive goal, and one that we believe that every ICT club should be able to achieve at some point. We believe that every ICT club should be having a website at least. They should be able to develop the website. And there's nothing better for these ICT club websites to be developed by the students themselves, because it's the students doing the projects, and they're the ones that are members of the club. So we believe that we can use that as an avenue for learning. So the second stage was coming up with the requirements and limitations, where requirements are what your system is supposed to do or what your program is supposed to do. And then you have to consider limitations. What are the limitations for your project, for your program? Are you limited by storage space? Are you limited by time? Are you limited by money? Yeah. So you have to consider also the mockups as well as some of the pseudocode that we talked about. Those definitions were shared in session 1. So moving on, you have to also be able to search for helpful technology. By helpful technology, I mean whatever you can leverage. There are a lot of technologies that you can use to automate some of these things in programming. You don't have to code things from scratch. Like today, you'll be seeing me using some technology, the Scratch technology, to build some interesting programs. So instead of me maybe coming up with my own technology or developing the program from scratch using a hard language, I'll simply be using the Scratch interface, the Scratch program. So then you'll be able to write your program, and then you will finally, you'll be able to test and troubleshoot. So when you test and troubleshoot and see that things are working, that means you've finished your program. So please keep this in mind. I think I'll be starting with this slide in each of our sessions to ensure that at least learners get used to this slide and get used to the process, so that we try to weave out this habit of people just sitting on computers and starting from zero without discussing with their friends, without thinking about what they are going to develop. Because I understand that sometimes in our laboratories, we actually get minimal time in the computer lab. So if you don't have a plan on what you're going to develop, things become really difficult. And even in the competitions, the NCC competitions, we normally give, there's only a limited amount of time that you can use to actually be able to participate in the competition. So unless you know how these particular stages apply to the development process, it becomes really hard for you to be able to achieve something worthwhile. So I will give a chance in our question and answer session for some of you to share with us some of the details of where you are in relating to this particular slide. Where are you? Are you guys working on an overall goal? Are you thinking about it? Have you reached a stage where you're analyzing the requirements? Are you working on the limitations? Are you thinking of them? Are you trying to assess? Because I believe at least everyone has to fit into this particular summary of the design and planning process. Because even if you don't have a program, at least you should be thinking about an overall goal. Maybe you've reached the design stage where you're creating some mockups and pseudocode. Maybe you finish your program and you want to share it with us. Are you testing and troubleshooting? Are you writing the program? Are you stuck somewhere? So this is what we are going to be sharing in our question and answer. So what brings us here today is basically block coding, explaining to you how we can actually leverage this advanced technology of block coding. So what is block coding? So before I jump into block coding, I think it would be nice for me to summarize for you at least what you should be able to take away from session 2. Some of the things that you should be able to learn before the end of this session. So at least by the end of the session, an ICT club member should be able to understand and to also know what we mean by visual programming. What do we mean by block coding? What do we mean? How do we actually use these blocks to actually build a program? How do you, can you learn to use the Scratch interface? Can you write at least 2 Scratch programs that I'll be sharing with you? So to summarize, block coding is where we use text-based commands, text-based computer commands, which are called blocks, that are grouped together in pre-programmed blocks that are dragged and dropped together to build computer programs, such as animations and games. So this is quite a long definition, but I tried to underline for you the 4 most important words in this particular definition. You should be able to at least keep it in mind that here, when we are programming, we shall be using text-based computer commands that we call blocks. So when I mention the word block, you should simply interpret that particular word as a text-based command, as you'll see. So these commands are what we group together to form the program. But all these blocks that we are going to be using are pre-programmed. In other words, we have some code behind those particular blocks that the programmer may not be able to use to see, but the people who design the applications that we are going to be using have designed some programs behind those blocks to enable them to perform certain tasks. So maybe the program is in Python, but our user may not be knowing the syntax, the Python syntax. So what happens is that we try to cover that up, to abstract it, so that our user, our programmer, can be able to also develop something, even if they don't know how Python works. So how do we actually build this? We do that by dragging and dropping, as you guys are going to see in my demonstration. So block coding, you have to keep this in mind. Block coding is also known as visual coding. It's called visual coding because you can actually see immediately what you're coding. You can see the code, it's already written, pre-programmed. You can just pick the block that you want, the block that is going to execute what you want, and then it will be able to do as you instruct, as the programmer instructs. So these blocks are basically puzzle piece shaped. They are puzzle piece shaped. By puzzle piece shaped, I mean they are actually shaped in a way that is similar to a jigsaw puzzle. If you guys are well versed with what a jigsaw puzzle means. So we get these puzzle piece shapes and then we build them together. I think this will make a lot of sense when I reach the demonstration part. So just to explain to you what a jigsaw puzzle is, when you're working with a jigsaw puzzle, you're given an image that you're supposed to build based on the puzzle pieces you're given, as you can see on my screen. So this is normally considered a fun game. So they give you a picture and then you're supposed to arrange these puzzle pieces in such a way that you complete the way the image looks, the image they've given you, whatever image it is. So, for example, you can be given an image of a dog when all these pieces have been put apart. Maybe they're in a box and you have to begin from zero, putting these pieces together intelligently. So you have to figure out, for example, if I'm to use this analogy or to use this particular example, you're supposed to know where does this particular piece fit. Where am I supposed to put, for example, the dog's tongue piece? Where am I supposed to put it? As you can see on our right there on our screen, we actually have a piece missing. So an intelligent program is supposed to know that, hey, at least at this particular part, this is the piece that goes there. So with our Scratch, we shall try to replicate that. So this is another example. As you can see, we have some of our friends there trying to work out how do we actually build this particular image, this particular logo of theirs. I can see there it is, I think, for inspirational women. So they're trying to actually build that particular image. And each puzzle starts with a single piece. It doesn't start with 30 pieces or 40 pieces. You begin with a single piece, then you attach another piece like that, as you'll see in my demonstration. So instead of us having that in the similar to what we have in the jigsaw puzzle, here we actually have the same, something similar, not the same, but similar. So we have our pieces, and these pieces are designed in, for example, in such a way. These are some of the Scratch pieces that we have, some of the Scratch puzzle pieces that we shall be using. As you can see, there are many of them. Actually, you can't fit all of them on the screen. I just wanted to illustrate the point that this is similar to what you've just seen in the jigsaw puzzle. So I think this will illustrate it a bit better. So we start with Scratch blocks that I will be explaining in my demo. So we are given the Scratch blocks on the left, and then we drag them one by one as we are building our program, maybe based on our pseudocode or based on our mockups. We can build the program one piece at a time, so that at the end of the day, the program does what we want. So we always have the Scratch blocks on the left, and then we have the editor on the right. So this is another illustration to show you what I actually mean by block coding. So on the left, we have maybe an advanced programmer, someone who already knows the syntax of a high-level programming language. So on the left here, we have our program that is written in C. So our program there is written in a programming language called C. But I'm showing you on the right that you don't actually have, it would be nice for you to know the syntax of C. But in case you don't know, you can still build something using a block coding. You can go on the right there and define the same program or the same function in this case using the block coding. So this can be done in multiple languages, and I'm giving you here another illustration of that. That's on the right. This time around, we have our program that is written in a programming language called Java that is normally used in mobile application development. So someone has written a short program there, a code snippet, and I'm representing it for you here in terms of code blocks. I hope that at least makes sense at this point. So what are some of the advantages of block coding? So block coding is very good for introducing coding to especially people who might not have any coding experience at all. So it builds that foundation like I told you guys. So it's important for us to use this kind of coding to introduce some of the computer science fundamentals that the learner can actually take advantage of. So it also helps us improve our problem-solving abilities, especially amongst our young ones or amongst ourselves. When we are building some logic, we want to find out if we can come up with a program that can solve a certain problem. This can be a very good foundation because you will see things happening in real time and you can test code immediately. So thirdly, it can also help us to build logic programs, in other words. So if you want to test out some logic, maybe you've written some pseudocode and you want to discuss it with your friends, you can test out immediately without having to build the entire program. So it helps one to learn to think, think creatively, reason systematically, as well as work collaboratively. Because you guys understand that in the world of programming, you don't actually get to build things alone. You can build things alone, maybe in practice, but if you want to build something really magnificent and something really big, you might need to actually discuss and be able to collaborate with other people. Because you find, like, for example, if I'm to give an example of Facebook that we all know, WhatsApp, these things are built by hundreds and hundreds of programmers. Maybe someone can bring in, can share a button, can create the button, and then another person can come create the database, another person can come maybe add another feature. So you realize that these teams are really big because that's how things work in the software development world. That's why in the ICT club, we don't only have single members. We have a lot of members, and that is on purpose because we believe that where collaboration is, people can be actually able to build wonderful things. So another advantage is that, just like I explained, most of our programs are going to be visually appealing, but they're not just visually appealing, they are also functional. Because something can be visually appealing, but when it is not that nice, I think all of us have had the proverb, I don't know whether it's a proverb or that says that not all that glitters is gold. But in this case, things actually, in this case, that particular phrase comes to life, in other words. So here, our things actually glitter and they actually work. They are worth something. So moving on, it helps us to sharpen our coordination and motor skills, as well as to build complex systems. So I'll be showing you in my demo, briefly, I will show you how we can actually use a microbit and a microbit, how we can actually program it using block coding without using any programming language necessarily that uses text-based commands. So I'll show you that briefly, not for purposes of maybe going into the microbit, but just to demonstrate that where block coding has reached is it has reached an advanced level where you can build complete systems just using block codes rather than text-based commands. So we can use block coding as well. As you guys will see, we shall soon be delivering the Raspberry Pis that have been brought into the country that we shall be giving to some of the active ICT clubs. So we want you guys to get used to programming some of these chips. So instead of you just being a software developer, you can as well learn how to develop, not only develop software, but how do you also get that software from your computer and integrate it into a hardware, so that they can maybe to try to create a system. Can you work with the robot? Can you get your program from your computer at school? Maybe use a flash drive, maybe use a USB and transfer that code onto a Raspberry Pi or a microbit and be able to come up with the creative system, maybe a system that solves something. We were actually impressed by some of the presenters, some of the schools that participated in the NCC last year. And we really saw that some of the learners are actually picking this up, that you should also be able to develop a system that works together, a program that works together with the hardware, something that is on the hardware side of things. So just to explain to you why we are emphasizing this concept of block coding is because we want at some point to be able to go through a microbit series. In other words, our microbit series will be teaching you how we use a microbit, a small computer that is very effective and quite efficient. And it's very interactive as well. So it's a pocket-sized computer. It introduces you to how software and hardware work together. So just like I've explained to you, this is what we want to be able to share with our learners, that now you can actually now being a software developer or a programmer, you can always take advantage of some of these devices to be able to create some of the products that can be shared with the market. You guys have seen dolls that are pre-programmed to do some things, maybe for kids. You've seen some robots in the army. People these days use technology to program those things. So I want to bring in this culture of people being able to touch hardware and be able to program that hardware. So our microbit has a LED light display, it has buttons, it has sensors, it has some input and output. So when you program it, you can actually see it doing wonderful things. So I just wanted to show you briefly how it looks like and how you will actually you'll be able to touch it, and whenever you see it somewhere, you should be able to know that that is a microbit, because we want this to be as practical as it gets. So this microbit can be used to build, I think you can see here a small system that is powered by a battery. So we want at least our learners, senior ones, want someone from senior one to be able to create something like this. Can you create a motor that is pre-programmed to do certain things? Can you use the microbit sound abilities and sound capacity to create something creative? So this is a set of a microbit set. It comes with a USB, the microbit itself, as well as a battery. You have replaceable batteries as well as another battery, which is chargeable. So you can always, it depends on what version you've actually gotten. But we are arranging that and making sure that at least we get to bring you guys, as promised actually in most of the ICT clubs. I remember personally, I went to most of these schools and promised people that we are supposed to bring them. But I'm glad that at least some of these things have been delivered in the country, and we are planning on how we are going to be sharing them with our learners. But unfortunately, we don't think that it would be the best approach for us to share the devices when our learners don't know how to use them. We think that it will be very important and imperative for them to be able to work with this, to utilize whatever we shall be sharing with them. So that's how it looks like when you've actually programmed it to do something. And in this particular example, someone had programmed the microbit to actually show a smiley face, as you can see there. So it's actually showing a smiley face. You can see the two eyes, the two red dots up. And then at the bottom, someone actually, maybe a young man, actually designed it to do something like that. So you can also use it to build robots, as you can see on my screen. I had a small example here that I wanted to show you. Hopefully, let me see if it can play. So this is someone who had programmed the microbit to actually put on to light when he snaps. So whenever he snaps, the microbit is able to light. I will play it once again for those who might have missed it. Yeah. So you can actually start with such a small program and then scale it into something you can actually sell in the community. You guys can come up with a system. You guys can come up with a system that is automated. Something that is automated in this case. So I'll move on. Can you hear me?
Yeah. Yes, we can hear you.
Okay, sorry. I don't know what happened. Maybe the network went off. So shall I just proceed? So the examples of coding websites out there, I want to share them with you in brief, because I don't want to really encroach on the time that I allocated for the question and answer session, because I think it is very important. So I'll just try to run through the slides just to summarize. So some of the examples, let me just try to share here. So we have Scratch Junior, and Scratch Junior is normally used for our learners that are between the age of 5 and 7. So that's why we believe that for the secondary schools, we shall not be using Scratch Junior, because Scratch Junior is sort of basic. So for us, we shall be using the Scratch, the real Scratch. So where we can actually take advantage of the many versions of Scratch up to the latest version, which is Scratch 3.29, that actually gives you more advanced features, as well as what we call Pictoblox. So Pictoblox is also Scratch, a version of Scratch, but which also gives you AI or artificial intelligence features that you can actually take advantage of and build some programs that are in the field of artificial intelligence. So Pictoblox normally uses Python. The blocks are coded in Python, just so you know, so that the learners can also take advantage of this. So I'll share with you, when we reach our Scratch series, I'll be able to share with you what in advanced detail, how we can build some of these programs in Scratch and Pictoblox. So we have code.org, we have Blockly, we have Code for Life. So our slide will be shared with the teachers as usual, so that they can refer to all of these. And maybe in their free time, they can also be able to check out some of these things. But for us, we shall only be looking at Scratch and Pictoblox when we reach that series. So in our sessions, we don't normally, we are not diving deep into the programming language, but at least we want, at least for the first session, so that we just make you aware of some of these technologies, so that maybe you can also go and check them out. So that's why we are taking at least some time every weekend to be able to introduce to you a programming language in summary, so that at least you can begin building something in that language. So Scratch, like I said, is a visual programming language, and it allows us to build interactive stories, games, and animations. So Scratch has about 125 normal blocks. And by normal blocks, I mean blocks that you can actually take advantage of to build logic directly without a device. So these blocks are quite many, and it would be impossible for me to actually cover all these blocks in one session. So I will be covering just a few blocks, just a few, to allow our learners to at least build their first program, their first two programs maybe. So the latest version of Scratch, like I mentioned, is 3.29.1, which you can download. I actually shared the link with our teachers. I don't know whether they were able to get it, but it is in our Patreon group. But I'm also going to share it in this. I'm also going to share it in these slides so that everyone that is on that has attended the session can actually be able to go to that site where we download Scratch from and then be able to get it. So there are 8 extension blocks that we actually use to build. Extension blocks meaning other blocks that you actually use when you have a device or something like that, that actually supplement the 125 normal blocks. Yeah, so we shall be seeing that in our practice sessions. So the latest version of Scratch can be downloaded from what we call scratch.mit.edu. So when you go to scratch.mit.edu, you'll be able to download a version of Scratch, any version that you want. If not, you can actually work on that particular website. You can develop programs on that particular website as well. So this is the Scratch interface. I want to share with you this Scratch interface before I even get into the programming side of things. So we actually have many things, as you can see. This is the one on the website. We have a graphical user interface on the left, on the extreme right, which shows how our program is actually going to be functioning. Then in the middle, we have our program built using blocks. So on the left, that's where we have our blocks. So we simply drag the block that we want to use and put it in the middle there, as you will see in my demonstration. So for Pictoblox, like I said, Pictoblox simply extends, is an extension of Scratch as well. So it is a graphical programming language, which is based on Scratch, that we use to build interactive games, animations, and robots, to program robots, sorry. So the latest version of Pictoblox can be downloaded from the stempedia.com. Please take note of that for those who might be interested in getting Pictoblox. If you are maybe into AI and you want to build some programs that are based on artificial intelligence, maybe to recognize faces, you can build some basic programs that can recognize your friend's face, that can recognize your hand. You can see how people these days use these devices for recognition purposes. Have you ever wondered how a recognition maybe camera works? A camera that can recognize someone from a distance, how does it work? So to build that foundation of knowledge, it is always good to go on to the Pictoblox website or Stempedia website, and then you try out some of these things. So Pictoblox looks like this. It's just similar to Scratch, so there's no big difference. So the only difference is that maybe you have some extra blocks, and there's some other features that you can actually use on Pictoblox that you may not get on Scratch. But I wouldn't advise someone to go direct to Pictoblox without having the experience of Scratch. So they should be able at least to work around Scratch, then be able to move on to Pictoblox. That's why today I'll only be demonstrating Scratch. Yeah, to encourage people to begin with Scratch, and then later on they can check out Pictoblox as well. It's also open source. So what are the advantages of Scratch in general, as well as Pictoblox? So when I mention Scratch, I mean Pictoblox as well, because they use the same programming language, visual programming language. So Scratch and Pictoblox, they can both run in a modern browser. So you can write your programs using a browser. Maybe you have your Mozilla, you have your Firefox, your Google Chrome, it can still work there. But it also has an offline version that I'll be using today, as you'll see when I share my screen. So it can also run on mobile. These days we have a mobile version. So in case you have your mobile phone, you can as well be able to use the Scratch platform, the Scratch interface. So this makes it very good because that means people have more devices to practice with. So even if maybe electricity has gone, but you still have your mobile phone, you can download Scratch as well and use it on your mobile. So it is also integrated with a lot of tutorials, as I'll be showing you in summary. We can actually use some of the tutorials that are inbuilt into the Scratch platform, especially the offline version. Yes. So I think someone should mute. I don't know who's that. So moving on, it has an online community, and that is a community where people actually develop some of these applications using these interfaces of Scratch, these programs of Scratch and Pictoblox, and then they share it with the world. So if you go to those websites that I shared with you, that is steampedia.com as well as mit.edu, you'll be able to get into the Scratch community for those who prefer to program on the internet. But I know some of our schools actually have internet challenges. That's why I'm deciding to demonstrate. I'll be deciding to demonstrate some of these applications using our offline version, because we think and we request the ICT teachers to also help our learners to install the Scratch, the offline version of Scratch onto the computers. It is very small. It's like 30 MBs or 40 MBs, and it can be installed in about 2 minutes. So we believe that if every computer has Scratch installed on it, then learners can get some time to interact with the interface, maybe through trial and error, be able to also learn some of these things. So how do we use these blocks at the end of the day? I think that is what even brought us here, most importantly. How do we use these blocks? I think our members should be able at least to have an illustration of how you can actually build a program using Scratch. Let me say your teacher at Bishop Cipriano Chihangiri has installed the Scratch program on the computer. So how do you start? Where do you start from? How do you go about testing, maybe building some logic? How do you go about that? So I want to get into the demonstration, and it will be very brief because I can see we have about 20 minutes to go, but I do really want to hear from our teachers and to hear from our learners. So I'm going to share my screen, my Scratch interface. Let me just try to stop sharing the presentation. Then I will share my my Scratch. So I think all our members can be able to see our Scratch interface, similar to the one that I showed you in my presentation on my slide. So this is what you're going to see when you install the offline version of Scratch 3.29.1. So this is how it will appear. Yes, I understand that maybe some of these things are a bit faint for some of you that are using maybe the projector, but I hope that at least you can get to see the interface in general, where you can find some of the things that I'm going to explain. So on the extreme right, I hope you guys can see my cursor as well. On the extreme right here, we have what we call a sprite. So a sprite is simply any character that will show up in your graphical user interface on the right. In this particular section, this box here, where you can see our sprite. So a sprite, the default sprite that they give you is this cat here that you can see on my screen. But you can always come to this tab here, this menu, and then you can always choose the sprite. So I want to just show you some of the basics, because Scratch is very broad, and on this interface you can do a lot of things. You can really do a lot of things. But please allow me to share with you at least what can get you started. So you can come here and choose the sprite that you want. So you can click here. As you can see, we have many sprites that you can use. You can use a bear, you can use a girl here, Abby, you can use Amon. There are quite many. And I think you can see, you can actually scroll down and you can actually select, you can use this motorcycle, you can use many things. But let me say, for example, let me just click just to show you that you can choose what sprite. I think you can see the sprite here on my screen, the apple. Yeah, so now we have a cat and an apple. But I will maintain my cat for a start. Then, additionally, you can as well upload your own sprite. Let me say, for example, you have your own image on the computer. So you simply go to the same menu, and then you click this upload sprite button. So when I click upload sprite, it actually, though you guys cannot see it, it actually brings me a dialog box on my other screen that allows me to select a picture. So you'll be able to see the same in case you want to upload and the sprite. So up here, we actually have, right here where my cursor is, we actually have some buttons here. I know maybe by now, some of our members who may not have any experience with Scratch, at least can be able to see these. I hope they can. So here we have a small field because I can't zoom in. I will just have to use the default size of my application. So here we have a section or a text box where you can actually change the name of our sprite. So I will just change mine here and I will give it a name. Maybe I want to call my sprite Jack, for example, just using an arbitrary name. So in this case, I'm calling my sprite Jack. I think you can see at the bottom here, the name of my sprite has actually changed. Then I can choose to actually change the position of my sprite, sorry. So sprite simply means character. So you can use any other name. Sometimes people use character, others use animation. Yeah, but the default name for these characters is called sprite in Scratch. So I can use, I think in senior one, we've learned about, at least by now, we should be able to know what the x-axis means or what the y-axis means. When you talk about the x-axis, it actually means the vertical plane in which our character is in. Then y means the vertical axis, in other words. So when I say x-axis, I simply mean the vertical. Then when I say y-axis, I mean when I say x, I mean the horizontal. Then when I say y, I mean the vertical. I think some of our students who take their mathematics seriously, this becomes very easy. So on the x-axis, I can show you that I can actually change the number instead of having 0. The default position for our character is actually 0, 0, 0. So it's sort of in the middle of the graphical user interface, if you can get me. So just imagine there's a plus, sort of a cross. If you consider our graphing in P7, in senior one, or there's a way we graph things. So if you consider that our character here is at 0, 0, x is equal to 0 and y is equal to 0. So if I put here a number, let me say I put a positive number on the x-axis, 20, you see that my character actually moves to the right a bit. Let me try to make it, to give it a higher value, maybe 50. You see that my character moves to the right. If I turn it into a negative, that means we are going to the left, because that is, we were moving the normal direction. Now I want to give it a negative 50. You see that my character moves backwards. So in case you want to move your character forward or backwards, you can use the x-axis. So on the vertical plane, I can also do the same. I can give it a positive. Then I'll move towards the positive y-axis side of the y plane. So I can also give it a higher one, maybe 70. Then I'll be able to move it upwards. So we also have the show tabs. So show tabs simply mean we can choose to show a sprite or not. And this comes in very handy when you're using, when you're actually using multiple sprites. For example, I was using the apple and I was using the cat, though I deleted the apple. But in case you had multiple sprites, you could choose to test out the way your cat is going to move on the screen, for example, if you're building that kind of program. By clicking here, you can choose to hide it. Let me say we had 7 sprites, and in this case, you want to test out only 3 of them. You can actually hide this sprite, or you can show it. Yeah. So since I want you guys to see my sprite, I'll leave it there. So for the size is very self-explanatory. You can see that here, when I increase the number to 200, I'll have my my sprite increasing by 100%. So size, we measure size in percentage terms, percentage-wise. So if I say maybe my sprite should zoom out 50%, it will be very small, as you can see. So I will keep it at 100, the default number, which is 100. Then I would like also to show you what the direction does. So the direction is basically all about degrees. I think by now we are well versed with degrees. So that is what we normally cover in primary and senior one. Someone should be at least well versed with degrees. We know that the circle is 360 degrees. So at 90 degrees, our sprite will always be upright. But if I try to increase this, the degrees, in this case, maybe from 90 to 102 to 270, you will see that my sprite will actually turn upside down because I've increased the degrees. Actually, it is, I think, negative 90. Let me try to, yeah, negative 90, I think it is equivalent to 270. So anyway, the point is you can actually test out how your sprite will look like at different degrees. So at 80, it will look like that. At 200, at maybe 170, it will look like this. Yeah. So at least for a start, we all know how to use the sprite to adjust this side, the right side of things. So we have a graphical user interface and we have the other tabs below. So up here, we have a flag. So this flag is the one we use to run our program in case we had a program. Then the stop button here, the red button, is what we call the stop button. It's used to stop the program. So allow me to take back my sprite to its default position, which is 0, 0. So our X has to be 0. So you have to learn this in case you want to take back your sprite to the default is 0, 0. Then here the degrees have to be 90. So it is always 0, 0 for the X-axis and Y-axis, then 90 for the degrees. Then the size can be anything that you prefer, anything of your preference. So let us move on to the top menu. Let me start with the top menu and summarize that. So for the file here simply helps you to maybe create a new file, a new document, a new file or a new project where you're going to save your program at the end of the day. Or maybe if you want to load your computer, load from your computer. If you want to load your program from your computer, it's already maybe pre-programmed. You've already written a Scratch program on another computer, but you want to transfer it onto another computer. You can always transfer the file and then you load it into the Scratch interface. You can also save. Let me say if we are done with whatever program I'm going to build here, you can as well save it on the computer. Then edit. Edit can be, so you can use these two tabs. Restoring sprite simply means restoring it to its default position. And then you can use the turbo mode. So turbo mode, we don't normally use it as beginners because turbo mode is normally used when you have, when your program is lagging, when your program is actually lagging and you have many sprites and it seems not to be moving on very well, lagging a bit, then you can put it in turbo mode so that the computer can execute it even faster to remove the lagging. So we also have tutorials here. So this is why today I just thought that it would be important for me to introduce to you the basics, how the interface works, rather than going into the intricate details of Scratch, because Scratch offers you a lot of tutorials, as you can see. These are inbuilt into that offline version that you're going to actually install on the computer. But as well as on their website, they also offer you that they offer you as many options as possible. So here you can actually go and begin with the first tutorial here in case you're practicing. So what happens when you click on tutorial? They give you a small sort of dialog box that shows you what you're supposed to do in the Scratch interface to build that particular program. So for this particular one, we're just getting started. So in this particular example, they are telling you to begin with what we call the move steps block. So that means someone in our ICT club in Senior 2 and simply come here and try out that program by putting this move 10 steps block in between the left and right interfaces, sections. Okay, I think that is a better word. So in this case, our sprite, at least if we run our program, should be able to move at least a bit. So though I think I will try to illustrate that when I begin the program itself, when I try to summarize the program. But all I'm saying is that in this case, we have to be able to follow these tutorials, to be able at least to practice the Scratch, because I couldn't, the 1 hour is not enough for me to actually even go through 3 programs or 4 programs. So please take advantage of this tutorial section so that you pick out whatever program you want to try out. Maybe you want to try out the Make It Fly program. You want to make this particular cat to fly. So they can show you how you can actually do it, showing you all wherever you are, whatever places you're supposed to click, what you're supposed to upload, what you're supposed to actually work with. So if your teacher installs this on the computers, please take advantage of the tutorials to be able to understand this better. Because as you can see, I'm just actually summarizing most of these things. So I will just go to the left here in the interest of time, just to summarize, and I will try to build a simple program. So before I do that, let me just try to also explain to you some of these tabs up here. So you can see here where my particular cursor is in the code section. Under code section, that's where we actually select the blocks that we want to use. So these blocks are arranged according to color and according to function. So you can, as you can see on my extreme left, we have the motion blocks. We have blocks that have to do with looks. All the blocks that have to do with looks will be in the color purple. All of those that have to do with motion will be in the color blue. Then those that have to do with sound will be in the color pink. Events, things to do with events. So let me say when someone clicks this, my sprite should do this. Then you have to go to the events section to program something like that. For the control section, this is where we actually control our program. Let me say we want to make sure that we loop our sprite to do something. Then we have to use the forever block. For example, in this case, we can use the repeat block as well. So the sensing, anything to do with sensing, you go to the sensing section. So for operators, in case you want your sprite to maybe say a number, to respond using a number, or to show some text, you might have to use some of these operators. So most of these blocks, actually, you get to learn what they do based on trial and error. As you can see, each particular code section has many blocks, which we may not be able to cover in one session. So here, you can be able to create some variables that you want to use. Maybe you want to store some information from the sprite, and you want to store it in a section in the computer. Then you have to go to my variable. Then you click on make a variable to create it. So I also have my blocks. My blocks is where you actually come up with some logic, you build your logic, and then you turn it into a customized block, your own block. You can actually add your own block to your interface. So please allow me to build a very small project at least, so that I can allow our members who want to get started immediately to at least put something into their interface. So I will just build a small script. So when I say script, I also mean program. In Scratch, when someone says I'm creating a script, they simply mean they are creating a program. So I'll begin off with a small block here in the event section. And please keep in mind that as you're writing your program, you must have considered the stages that I explained in the beginning of the session. That is the 7 steps of designing and planning the program. So by this time, I'm just assuming that our members have maybe discussed a bit and they've come up with the sprite. They've realized that maybe they want to use the elephant sprite, and they've already maybe considered the requirements, the limitation, and they've chosen the technology being the interface right here. And then they've come up with their pseudocode. They know how their sprite is supposed to move around the block, around the graphical user interface. And they are now jumping into stage 5, sorry, where we actually write the program. So right now I'm on stage 5, but I just wanted to make sure that at least you know that any serious programmer should be able to know which stage they are at, and when they've actually put the previous stages into consideration. So just like I've explained to you, I've considered stage 1, stage 2, stage 3, stage 4, and now for presentation purposes, I'm considering stage 5, where I have to develop the program. So for a start, I'm going to use a quick, I'm going to go to the events section, and then I'm going to click on I'm going to choose the when clicked block. So like I said, we shall learn what these blocks do based on based on the practice session. So when someone clicks on the sprite, or when someone clicks, when someone clicks on the flag, this flag here that I showed you before, the program will actually start. Our program will start. So that's why in the beginning, I'm putting there the when clicked block. So secondly, I will come. So if you guys notice, when I click on the flag here, nothing happens because I don't have any program pre-written there. So I need to write the instructions. I'm the programmer. So I need to give the instructions to the computer so that it can do something. So I will go ahead and go to the sensing section. So under the sensing section is where we can find another block called the ask what's your name and wait block. So I'll just come here as a member of the ICT club in the sensing section and look for the ask what's your name block. So I'll just try to check for it here. So it's right here. It's right here. So when you drag some of these puzzle shapes and try to put them under another puzzle shape. So you always have to choose shapes that actually fit. They look as if they're going to fit, as similar to what we saw in the jigsaw puzzles. So you'll see that actually your block gets attached to the when clicked block. So when I run this program, you'll see that now our sprite is actually saying something. It's not based on sound, but it's based on text, that we have a section in our graphical user interface that is actually asking us to respond to the sprite. The sprite is asking, what's your name? So we should be able to respond. So for example, if I respond here, the program will actually end because there's no other instruction. So the sprite simply says, what's your name when I run it? So to run the program, remember, you have to click on the flag. Then additionally, you can double click on the block itself to be able to run the program. So this is also a simple program, just simply a simple program, the first script that I think anyone in the ICT club should be able to execute, that you should be able to have at least to use the ask question block. I call it the ask question block because, why do I call it so? Because you can actually change what your sprite is actually asking. Maybe you want to say, what day is it today? You want to change that. And then you put a question mark. So you can actually run the program once again. I will just stop it. Okay, it's already doing so. So it is saying, what day is it today? So you can always change the text to your preference, depending on the question you want. So I will just, so I can see we were running out of time. Let me try to summarize. Let me just try to summarize here with another block. Let me just remove this as we summarize. I'll just use another block for this purpose. Let me just introduce a move steps block. Move steps block, and I'll use another control block, maybe forever block. The forever block, then I will combine it just to show you another fun, just a fun program, for example, just to summarize our session, because I can see we've really run out of time and there's a lot to cover. So I'll try to execute this block. So you can see what my sprite is doing right now. So my sprite is actually showing us that you can actually move your sprite alongside on the screen. You can move it around in different directions. So I've just said, just summarize for you this program. I'm saying when I click this flag, we should be able to move the sprite 10 steps in a direction where it is turning 15 degrees around my graphical user interface. But I want to do this in a manner that it is looped. In other words, it rotates forever. It keeps on rotating. Yeah. So with that, please let me end the presentation in this case. For the Scratch, I will just try to also, in 2 minutes probably, 2 minutes just to show you why we are encouraging people to build programs in Scratch using my microbit editor. Just 2 minutes, I can write a short program that can at least show our members that there's a lot to do. There's a lot of work to actually cover. There's a lot of programming out there that you can actually do, so that you can also get to a point where you can build great things. So I hope on your screen you can actually see my editor here. So this is a microbit simulator that we actually use to program the microbit. So you don't need any advanced stuff to actually do some of these things. We only use blocks, and that's why I recommended it to our members at CAWA as well as UCC and the partners. So I will simply go ahead and try to choose a block here, a basic block. Like I said, you can build a very nice program here in 2 minutes. So I'll go to the basic blocks, and don't worry about this. We shall get into the microbit series where I will share with you everything that this microbit can do, all the complex things, the advanced features, and also and so on. So what I will do, what I'm going to do. Yes. So with that, please allow me to give an opportunity to our members to share something, because as you understand with programming, you can go on and on, we can go on and on, we can actually talk for the entire day, but we have to respect time, the teacher's time, the students' time, as well as the school's time. So please allow me to end here and at least get some feedback from you. So I will invite
Our club members.
Yes. So thank you very much for sharing. Anybody else? Maybe you have a question? Anybody? Before we close, can someone from Ngora Girls maybe say something? Maybe the teacher? Bishop Cipriano again. Someone wants to share? Yes, you can speak up.
So you talked about how internet is a hardship in very many schools.
Yes, yes.
Can you give us maybe the best internet providers and how we can possibly solve that?
Yes, I think I personally launched the club at Bishop Cipriano. I remember very well. And we discussed some of these issues for those who were able to attend the session. So I explained to you that we're actually working together with UCC to see how we can actually introduce a more reliable internet provider, as well as how we can actually leverage some of the technologies that are around to be able to support as many schools as possible, because we understand that internet is expensive, and that is what I normally hear from most of the schools. But for this particular, in the context of this particular session, I advised the members to actually download the offline version of Scratch, which does not require any internet, because I understand internet is important, we all want it. But as you can see, I'm also using the offline version. I'm not going for the web-based version that requires internet. So please, my members at Bishop Cipriano, please try to use the offline version for a start. I'm sure we shall pay you a visit again and try to discuss some of these issues as we address them as we go through the program. So I don't know whether we have any other questions as well.
No, thank you.
All right, thank you very much, our members from Bishop Cipriano. And I want to say thank you to Mr. Morris, who has made sure that, I don't know whether he's the one around, but whichever teacher at Bishop Cipriano that has made sure that the students get to participate today, we are really grateful and we really appreciate the time. So,
I'll send it.
Okay, yeah. So someone from Padibe, as we close.
Hello.
Hello.
Hello. Yes, thank you, Emma, for the great introduction.
Yes.
I'm Teacher James from Padibe. I'm here with my students. Only that I can't put the camera to see. They're very excited.
That's great.
I was able to install the offline version, and I know from now I'm going to really use the project to start with serious project.
Yes.
So we appreciate it, and we wish you the best.
All right. Right. Thank you very much, our members from Padibe Girls. I can see you have a very serious patron there who's making sure that at least at the end of the day, you get to learn something, something new, something that will supplement your ICT curriculum. at the end of the day. That is really great. And since it is already 4:30, please allow me to close the session here. And I want to appreciate all the head teachers, the teachers, the ICT patrons that have made sure that at least their schools get to participate. And we want to encourage you to at least make it every Saturday, because we shall be introducing a new concept before we get into the specific series for each of these. Because now, like for today, I've introduced to you Scratch, the microbit, but we can't cover the intricate details of all these things in one go, because I believe that these things require a lot of time to practice and to understand. So with time, we are going to come up with a series that actually helps us to delve into some of these programming languages like Scratch. I'll still come back and show you how we can actually build